just getting started a few minutes late. I'm joined tonight by my friend Zenhaver. He's going to be helping us out with a couple of projects, and I'm really excited tonight because we have a couple of things done. We have a couple projects done, actually, that I've been wanting to talk about. So we also have a new camera setup. So this is I believe this is the first time we've done this stream from this location. This is a newly set up workstation that I have upstairs with all of my tools and other toys and things. So it's a little bit of a disaster right now. There's a lot going on, but that's because I've been busy working away today on stuff. So welcome, Zenhaver. How are you today? Yeah. Wonderful. All right. How's your 3D printing hobby been going? Oh, well. No problem. It's exciting. Anything any projects you care to share? Oh, wonderful. It's good. That's great. Yeah, I find I rotate through those with some frequency, for sure. One all-consuming hobby to the next. That's life. So I have some fun things I'm so excited to show you. So first thing is I completed let's see, where's the best place to show this? Probably this one right here. I completed the macro keyboard, as you can see here. We have, these keys are maybe a little not exactly the right keys labeled correctly. I don't really know. Very bad security system. Yeah, there's some numlock involved. I don't know. We have MX blues across the bottom row, which is there a little clicky. You can probably hear that pretty well. And then I should make sure that we can hear you. Can you talk just a little bit here? No, I don't know if this is actually coming through. I better check this one more time. Yeah, I bet this is, people have just been hearing me talk to myself. You'll have to give me just a moment here. Whoopsie daisels. Okay, if you want to speak a bit here.
Testing 1, 2, 3. I am speaking.
Yeah, there you go. Nice and loud.
Hey,
Perfect.
welcome to everyone on the stream. I'm just joining now for the first time.
Yep. Definitely wasn't talking without microphone chat. How about now? Have I never actually said your username out loud?
Hello.
Nguyen. Cool. Thanks. I should probably figure out how to say your name. Awengun. Okay, thank you. Thanks for that phonetic spelling. So here we have the macro keyboard. There's some nerve-wracking parts going on here. I was definitely not feeling super confident about all these things that I did here. I don't have my USB microscope hooked up yet. I am just absolutely pushing the limits as to what this laptop can handle USB-wise. I don't know if it will actually like me plugging in that USB microscope, but we do have some like PCB style LEDs here that I managed to solder, which I'm kind of glad that we don't have a better view of them because it's dreadful how badly they're soldered.
Those are like surface mount LEDs?
Yes, two surface mount LEDs, and then I actually have two surface mount resistors in the back also that I've soldered on. So it was really good to get those working, and I tested it all out and it works. So I also had to solder all these jumpers in the back. I think I'm going to do a whole stream dedicated just because I have a couple of these. I have two of these modules. I think I'm going to do a whole stream of just building my second one of these. pretty soon, because I did learn quite a bit from it. So I think as far as 3D printing goes, I think I have some CAD work to do, some modeling work to do, and a favor to ask of you on maybe making a case for this thing.
That sounds excellent.
Yeah, so let me plug it in. I mean, it's not going to really do a whole lot because...
So you mentioned the bottom row are MX Blues.
Yep.
What's the top row?
They're browns.
Browns, my favorite key switch.
And that's because I have just an absolute mess of browns. These are all MX browns. I pulled these off of a keyboard that had a very unfortunate ending rather recently. This is maybe 6 months ago. Maybe it will be hard to see, but this chip here definitely had some magic smoke happening. So this is the main chip from this keyboard. This is a mechanical keyboard, and thankfully it was a hot swappable keyboard. So I was able to pull out every one of the MX switches to use for other projects, and maybe ill-advisedly, I don't think I could actually replace this chip. I'm not good enough at soldering, nor is that I don't have a lot of faith that it didn't fry because of some other defect. But I've started to steal some of the LEDs from this chip as well.
Yeah, desoldering burnt out chips, sourcing the correct chip from somewhere, and resoldering fine pitch surface mount chips is really that's really getting into an area of circuit repair that I certainly am not at.
Yeah, but I'm definitely not above stealing the nice bright RGB LEDs out of here and using it for my next keypad project. I actually managed to get 2 of them soldered on already. So Ryan Bates, the guy who made the keypad that you see here, just released a new version of the slightly larger version here that has spots for RGB LEDs. So this has, how many keys is that? 12 keys? 13 keys on here. It also has a rotary encoder and some other things, but it has these LED spots in here to solder in to use for RGB keys as well. So I got 2 of these PCBs. These were $4.50 a piece for this PCB. This mini one was $1.50, and I think I'm having a wonderful time making these things. I'm really learning a lot. Mainly that surface mount things are super freaking small. Holy cow. It's ridiculous.
Yeah, I'm actually pretty surprised that the designer would put a surface mount parts on sort of what seems to be a sort of a beginner style project.
Yeah. It was a lot. You know, it wasn't too bad. It's just nerve-wracking, right? And like getting the right polarity and stuff on surface mount LEDs is a thing. It's challenging. But you can see I got them working here. So this is mode 1, mode 2, mode 3 has both of them on, and mode 4. So I apologize. My screen is over here, so I keep just turning my head and looking this way instead of actually facing the camera as I look at things. So I did make a new, let's see if this works. Hey, there we go. But now everyone can see OBS. So this is the code for this keypad, for which I need to really dig into quite a bit more. But he did a nice job. He has a lot of documentation, a lot of comments and stuff in here. And he has the keys basically just labeled alpha key, 3 through 16 on this keyboard printout. Probably starts with, so it looks like some of the other controls are up here as well. But anyway, if I open up Notepad, you can see that the keypad does some stuff. So I'm pretty psyched, to be honest. I was not expecting this to go so well, especially after the nerve-wracking soldering that I did. And probably not very precise of... Oop, I just locked my computer. Can you still hear me all right?
Yes.
Nice. Cool. Let me log back in here. So yeah, keypad's working. Pretty psyched. So now all I'm going to do is I'm going to work with my friend who I'm building this for, and going to see what he wants for key location and stuff, and like where everything should go. So the let's see if I have it open. Actually, I'm gonna Google this, and we're gonna go to this guy's name is Ryan Bates, and if I look at the mini keyboard on his website, this is the mini keyboard. He has this really nice planogram template that has like kind of the layout for each of these things. So I'm going to send this to my friend, and they can kind of write in what kind of commands they want. And you can do multiple key commands and various things like that. So you could do a Control-C or Control-V all in one key. So yeah, so I'm pretty excited that this worked. I'm surprised at how well this has worked. So that's been one of the big things I've been working on. I also worked on this. This is something I kind of talked about last time. The last time we worked on things, or the last stream. You weren't on Zen, but that's just fine. And I started to put it together, then got frustrated that I couldn't just solder it right then. So what this is it's essentially something that I could have easily purchased for a lot less work. But instead of buying a 4 relay panel that was all ready to wire, I bought singular ones. So I got 10 of these singular relay things. And then, you ready? I soldered on this prototype board and got them all hooked up. I have not tested this yet, but I'm very confident about it. Wired all the positives and the negatives together, and then left the control wiring for it. The inputs are all independent. So I'm excited to test this out and see if I can get this relay firing on all 4 of these.
That looks great.
I know, I was really excited. It's like, oh, this kind of looks legit. Cool.
Mm-hmm. Yeah, some very nice wiring there.
Thank you. All of my work in trying to build flowcharts that don't overlap with one another really helped.
I love that.
So it's a good skill, and that's, I've been thinking about hobbies a lot lately, as I'm sure, with any kind of thing, like especially like a 3D printing hobby or anything that's a little more expensive, is that you can get down about like, oh man, I'm spending a lot of money on something that's not very useful. But it's kind of fun to find those things that I know that if I spent a lot more time working on this kind of wiring, that it would just make me better at making flowcharts. It's kind of fun to look at those kind of cross-training things that you can learn from each of these. So maybe too philosophical for hobbies, but I'm excited to figure out how much I can learn from 3D printing. I've definitely delayed on my purchasing of a 3D printer. I think it's probably coming the next week or two. Essentially, I ordered it from Micro Center for pickup, and then the day before pickup was they shut down temporarily for cleaning for COVID, and then the next day was New Year's Eve or day or something like that, and they were like more than twice of what Google expects to have the number of people in there, so it was like packed, and they closed at 6, and I was like, I didn't go and pick up my thing, and then they were out of stock afterwards. So I'm waiting for the Creality Ender Pro V2, Pro 3 V2. And so once they're back in stock at Micro Center, I'm going to go pick that up. But I was like, I don't want to be around a lot of people to pick this thing up, so I'm going to not and wait. So
yeah, that seems like a pretty safe decision.
Right. Good to be safe. So today, what do we want to work on? So I want to test this out. I had written some sample code for this, and then that is downstairs on the other computer. So I don't think that's going to happen. So what we'll probably rewrite this. When I did this before, it was not much more complicated than the blink command. So probably what's going to be happening is I'll set up a button or something on the breadboard, hook this up to the breadboard, and then we can just write a quick, every time the button presses, maybe it goes down to the next one of these, or we set up 4 buttons or something like that to test it. This has a future in the greenhouse project for turning on and off all of those fun things. The other thing from the last week that we worked on this was trying to use the IR module, the infrared module. The code kit from Elegoo, I think it's trash. I think it's really not so good. So I was having a lot of trouble with my Arduino basically, crap in the bed every time it tried to run this piece of code. And I think it's like getting stuck in some kind of loop or something like that, or it's waiting for some input and needing to be reset or some other thing like that. So I don't know if we want to look at like making a reset key or something, a reset button that we can add, or if there's anything else that you have advice on for how to get this IR thing to work. But I know that is contingent on how much experience you have with IR modules and things.
I don't have much experience specifically with IR modules, but if it's a problem of trying to sort of deduce what the tutorial is trying to get you to do, and maybe some like datasheet investigation, I do have a lot of experience with that. So
excellent.
It might be a fun problem to troubleshoot.
All right, cool. So so we'll work on that. Thank you. I think that's going to be really good, because it kind of just, if you don't have a lot of troubleshooting experience on something like that, you can kind of feel like you're up the river without a paddle. So we'll look at that today. And then I don't know what else. I think that could take up quite a bit of the time. Another thing I'm interested in doing is taking this thing that I have here. So this is just what do they call them? I have to look at this box every time. The single row pin header socket connectors. So I have these set up for an Arduino Micro, like I used for the keypad, but I'd like to see about for the project for the treadmill that we talked about a couple weeks ago, using a micro like this and trying to understand where all the pins are and how to utilize that. And have you done a lot of that yet?
I've done some of that.
Cool. Another thing I'd like to talk about eventually, maybe not today, is this ESP 8266 starter kit that I got. I opened it up. I was really excited to get like another kind of training thing. I was just spoiled by that dang SparkFun Inventors kit. I really was, because this starter kit tells you nothing. This is the entire manual that comes with it.
Wow, that looks pretty sparse.
Hey, Chef Rex, welcome. Yeah, it's really sparse, and then like I go online and try and find more information following this QR code for this wiki, and there's literally one project, and it's a Blink project. That's it. So I don't know. It didn't actually show me how to connect anything or hook anything up. It came with a sticker for resistors, so that's good. And a couple other jumpers and stuff. I mean, I'll use this other stuff. Like I already used 2 of these buttons. I used 2 of these buttons for the keypad project, so I'll utilize those. Looks like there's a photoresistor, another IR receiver module, some resistors. There's 2 RGB LEDs in here and some other LEDs. Then we have a this deal here, which is I think the USB connector for this chip. So, there's some useful stuff in here, but I was really just hoping for a project, I'm just so surprised. So this is the ESP chip here. I wish I could set this to focus a little better. This is the ESP chip. I don't know, we'll see. It's a wireless chip, kind of like the ESP32. I think it is, right? That's a really popular one. But, you know, so I don't know if we'll work on this at all, but definitely going to steal some of the parts out of it. Do you know of any other starter kits that have better instructions and things?
Nothing comes close to the SparkFun Inventors Kit. I haven't. I've been out of the starter kit game for quite a while, so
sure. Being a literal professional.
Yeah, yes, literal professional and electrical engineer.
Yep.
No, the only one I've really had experience with is the SparkFun one. So I have not personally come across some of the same troubles that you're having with some of these other starter kits.
Yeah, just like poor code quality and really no explanation on things in the helpful guides. So, yeah, you know, it is a little frustrating, but I'm really glad I started with the right one. So definitely for anyone looking into getting into this kind of stuff, 100% recommend the SparkFun Inventors Kit. You know, it's $100. It's a little more expensive, but you know, you could also no, I would just spend the $100. It's such a useful skill. I don't know if I've gotten $100 out of it yet, but we're getting pretty close on this. I definitely feel like I've learned $100 worth of stuff. So, yeah. So let's see. What did I do last time? I did last time played around with a rotary encoder and got that to work pretty well. That was cool. So this one just kind of cycles through various serial things. So I don't know if I can get this to work quite yet, but
how many steps does it have?
I don't know. I can't remember. I think somewhere in the 30s. 30 something.
Cool.
Let's actually have a cable for this. I have not used this on this machine yet. We're on a totally different right now. I probably could show you all. So my one of the big projects I've been working on is actually what we're streaming on right now. So I'm going to just direct this camera here at my streaming setup, which I'm pretty psyched about, is built into a Pelican case. So all this stuff is all Velcroed in. Definitely had trouble with the USB things. And yeah, Owen Gun, definitely we have our USB hub here. I do need another USB hub because I'm just overwhelming it with devices. So, but that means that the computer that I was doing all the other projects on is not this one. So we kind of have to redo a lot of those things. Let's see. Chef Rex said, I'll tell you, around Christmas time, my grandma never wants to take photos with us. She becomes a photo resistor. Not quite what you meant, though, is it? Yeah, you know, there's a few flavors of photo resistors. I definitely know several. Yeah, this particular one turns off when it's exposed to light, so it's more of a, you know, it's maybe like a vampire sensor or something. I don't know, something like that. You got any good photoresistor jokes there, Zenhaver?
Nope.
Dang it.
I do not, and nor do I condone any other such photoresistor jokes.
Please cease and desist your photoresistor jokes. You know what I'm going to do? I'm going to actually lower this just a little bit. Ah, dang it. Headphones are too tight. One moment. Yeah, zooming in. There we go. I like that. Thank you for your patience. Hopefully there's not too many chords in view. You know, this whole streaming thing is really... I think I get pretty wrapped up in just the camera stuff. It's so much fun. I'm pretty excited about it. So here we go. We have a little bit of a better view now. So I'm going to... Well, we want to get this board hooked up first. So it shouldn't be too painful, I guess, because this is just the our Arduino Uno, right? So hopefully y'all can see my screen okay. I'm gonna go down here. I'm gonna open up a sketch. Where's my downloads? Kind of want to start with Blink. And let's just see if we can get this sent over here. So I'm going to go to board from Arduino Micro to Arduino. Which one is it? Do you happen to remember, Zenhaver?
I do not off the top of my head. You're trying to speak with the board, the red board?
Yeah.
I think it's an Arduino Uno.
Okay, problem updating the board.
Different COM port?
Yeah, let's try it. This looks like the problem I was having earlier. Well, looks like that might have been it. Yep, different COM port. Man, that's useful, knowing the different COM port thing. Tell ya, that has been the problem on a number of different occasions. It's been so nice to be able to diagnose it right away. So thank you for teaching me about COM ports. So, okay, now that we know that I can talk to it, let's, what should we test first? Should we test our relay thing? How should we go about that?
Sure. Sounds good to me.
Okay. So, here's our power over here, and we need that for our relay panel. Thankfully, these relays will they have their own LEDs, and we'll flick that LED to a different color or turn it on or off, depending on if it is active. So even without having anything connected to the relay, we should be able to see whether or not it's working. So that should be good. So let me just verify wiring here. So so this one goes to center pin. Center pin's negative, so this is negative. I'm going to plug in the negative right away. How would you recommend labeling something like this? Like which of these pins goes to where?
I don't know.
Chef Rex making jokes over there. A breadboard, not a red board. Yeah. Nice attempt, Chef Rex. Yeah, do you think like a... I've seen people use like micro whiteout pens.
I was going to say, do you have like any red Sharpies or anything? You could label the one input that goes to power red or something like that.
Oh, that'd be good.
I'm not sure. A micro whiteout pen would probably do okay as well, although there's not a lot of room
to
write things in there.
I just wonder what other people do for prototyping boards, just to remind themselves.
Do you have a label maker? You could like print out a very small label.
I could do that. I have some.
Affix.
I could do that. I think. I do have a label maker that can print quite small. So, I love my label maker. I just thoroughly enjoy it. It's I think it's a...
Yeah, you could basically print out a very small replication of the input pins and just label them accordingly. Something like that.
Right, just like the 1, 2, 3, 4 for the input pins. Would be good. And I also, I don't know if this is how you would have done it. but I put the positive and negative on the opposite sides of the board. So this one here is the positive, and then this one over here is the negative. Should I have put them right next to each other, you think, and then put the inputs on the other side?
I would say it's quite common to separate them, actually. Have one at either end. That would seem like a pretty common convention to me.
Okay, cool. Nice. So, neat. All right, so I got that plugged in. And as far as which one is which, I have no idea. You know what we could do? We could utilize our rotary encoder, couldn't we? That could be fun. And so when the rotary encoder is in a specific range, it'll turn from one relay to the other.
That sounds very complicated.
Fair. Let's use buttons. We have one of the things I really like about these kits is that they just give you like a bunch of these really easy to use components, right? They're just like these ones that are easy.
So your thought is to tie a button to each of the 4 relay inputs?
I think so, yeah.
Okay. That could be fun, yeah. You
What?
could also digitally control them just from the Arduino, so that you could, in the code, like write a pin output to high or low to control the relay.
Oh, no, it's going to do that. So it's going to use the buttons as a digital in. And then,
I see. I see. Okay.
And then digitally control it still. I didn't actually think about the other route, which also makes total sense.
If you were trying to test it, you could just bypass the buttons entirely and just write a small program that like wrote one and then delayed for a couple seconds and then wrote the next one.
Let's do that. Then we're testing one thing. That is a better choice. Otherwise, we're testing our code for the rotary encoder or the buttons too. Wouldn't want to mix that up too bad. So I'm just going to hook these up to starting at 8 and just use digital outs.
Real quick, remind me on the operation of these relays. There are 3 input pins for power, ground, and signal.
Yep.
And 3 output pins.
Yes. So, so basically, the pins on this side are where we do the controlling, right? So this is where we have your positive and your negative. So positive 5 volt or positive or negative at 5 volts, and then your input. So the power, positive and negative, control the actual relay box, right? So they control the magnetics that are inside the relay. So basically, these are responsible, and these control pins are responsible for powering on the electromagnet to close or open the switch. And then over here, this is the mains power, or as all the British folks whose YouTube videos I've watched would call it, the mains power, where you have things that are powered via the relay are going to be hooked up over here, and it's completely separate from this side of the PCB to the other.
Got it. Excellent.
So, so on this side you have NO, COM, and NC. So normally open, common, and normally closed. So you can set up your relay to always be on until it's powered up, and then it turns off, or the other way around.
Got it. We actually have a very similar type of switch on some of our pressure transmitters that use the same terminology of normally open, normally closed, and common. So nice. That terminology is very familiar to me.
Excellent. My jumper wires are almost not long enough. Boy, I'm really enjoying having these headers that I can set up and solder onto things. It just makes it feel so cool.
Yeah, I'm pretty impressed at the setup you have going here.
Thank you.
Let's hope it works.
Let's hope it works. Let's hope I didn't cook anything. That's it. That's all I need. So we have our positive and negative. or 5 volts in our ground, sorry, over here, and then all we got to do is power it up. And I'll let everyone know. I'll describe smells as best I can if it gives us any magic electronic smells. I don't think it will. So, okay, so that's powered on. All 4 of them lit up. So let me...
And that LED on the relay just indicates like it is successfully is powered on the control side?
Yes. Yep.
Excellent.
There are 2 LEDs on here. So you have a green LED over here, over on that side, and then there's another one over here that I believe is blue that we should see once we have it powered on. They also have a very definitive click to them.
That sounds very satisfying.
Yeah, that's it. It really was. So let's go 1 to desktop. Sorry for having to show everyone my stream info. Okay, so pin mode. So we're using pins 8 through 12. So we're going to set all 4 of these. Oh no, why would it do that? That's so not organized. Get back
Probably there. Selected the 2 spaces at the beginning. Each time you go to a new line, it tries to feed you to the... basically inserts those 2 spaces automatically.
It's trying to be helpful. We don't need or can use any PWM for this. Any pulse width modulation. Okay, so set all those to output. So this is going to be easy with this blink sketch. This is pretty straightforward. So it's 2 seconds. So then let's do... Let's actually make this wait for 3 seconds. So set this to 9.
Is the... what am I trying to say? It feels like we are seeing only a small subset of your screen on the stream.
Yes. Thank you. Are you still only seeing a small subset?
I am seeing multiple windows that you are dragging around at the same time.
Yeah, OBS is being a little weird. Does it seem as though I have the entirety of my...
Yeah, that seems like you have the whole screen filled with your editor now.
Good. There's also a camera that's supposed to be looking at me, but I think something weird happened. Something weird. Let's see if we can... Yeah. This is not what I wanted. Oh, that's because I chose the wrong thing. Sorry, gang. There we go. That's better. Thank you. I'm trying to get this to work right for the stream, but essentially I put the wrong thing on my... I can see into forever. I put the wrong thing into my Stream Deck, and thus it was confused. Okay. There we go. That look a little better?
Looks a lot better.
Thank you. Okay, so what we have, thanks for your patience, everyone. So set the pins as outputs, and then a 2-second timer to turn each of them on for they turn each on and off for 2 seconds, and then they wait for another 3 seconds, and then they proceed. You know what? I kind of remember that maybe setting it to low is actually how to get it to work, but we'll maybe just see what this does, huh?
Yeah, that's a good question. Are they active high or are they active low?
I think they might be active low. What would happen if I set this to active, or if I use this right now and it starts to active low? Would they all just turn on one after the other?
I would assume that all of the they'd basically all be on, and then you'd be turning each one off in turn, which is not going to be a problem at all if we're just testing. I think this will be fine.
We'll learn something when we test it. Got a friend of mine, every time he smokes up, he's not very active high. Thanks, Chef Rex. That is helpful. So, compiling sketch. Seems as though it has worked.
I can hear the click.
Neat. Let me
get us the view. Show us the goods.
Sorry, I gotta. Okay. So I think there's a mistake in my code because it's turning on and off this one twice, and then it goes to this one. So I think I missed one of them. Yeah, I do 8 twice, and then I go to 9, and then 10, 11. So it looks like they're all working. Sweet.
Very cool.
This feels very neat to me. I'm excited about this. So there's... Ooh, and I did get them to be in the right order too, as far as my wiring goes. Nice.
Does it just go around clockwise?
Yep.
8, 9.
So 1, 2, 3, 4.
Excellent.
Cool. Yeah, it physically moves whenever it does one of these things. I'm gonna get rid of that extra 8 so it doesn't confuse me. There we go. Cool. So some of the next things I'm going to add to this project, kind of hoping on doing, is I want to get one of these displays in here just for reading things like temperature and what have you. But I think before I proceed with this and getting this in place, I kind of want to get an enclosure printed up so that can have, because these fit so nicely into an enclosure, like they're set in a little bit, so I could definitely see having this be just big enough for this to pop through and then having all the wiring and stuff in the back. So I've got 2 of these. One came with each of the kits, and I think having one in the greenhouse project would be a really nice use of it. For the various modes and stuff. So that's one of the next things. The other thing is basically just putting the temperature and humidity sensor on this and having some of these controlled via that. So I'm probably not going to do that on stream just because it's going to be a little bit of, like, I know how to do it, pretty sure, with the various if statements, but we're not too far from having a functional greenhouse project. I think we're getting there.
Very cool.
Yeah, I'm excited. So that's one project. So any thoughts on any of the controlling of this or any of the wiring? Any recommendations on anything?
No, I think that this is a really solid, little mini project. Looks
Nice.
like you've got that little prototype board put to good use and soldered up pretty effectively. So kudos all around.
Thanks. Do you know how I would use these things in the ends? They're like, they look like it's supposed to maybe sit into some kind of slot, but I've never really seen, is this like what you'd expect to see on like a PCI Express or something?
The big wide pads?
Yeah.
Mean?
Yeah, what are those for? I wonder if it's like solder jumping from one to another or something.
Excellent question.
Yeah,
that could be. That could be.
Because
that could be a way to feed like power and ground between adjacent prototype boards, maybe.
Yeah.
I'm
not sure.
Not sure.
I do have some of these just absolutely adorable breadboards. Look at how tiny this is. It's just such a nice little small guy. I don't know what to do with it. These ones where you solder on seems just so entertaining to me, I think. But maybe this will have to be my wristwatch project, like we saw on Twitter a little while ago. So let's do our next project. So I'm going to unplug this. The next thing I would like to work on... I'm so psyched that this worked. I'm a little tempted to try and control some of these right now with humidity and temperature, but that should be all right. We'll save that. It's almost a little crowded, isn't it? Great in that spot.
Just crowded enough.
Just crowded enough.
Just enough space.
I did find my junk Cat 5 cable and was able to seal some wires from that. So that's how I did all the wiring in the bottom of this prototype board. I'm a little... The, ones that are white with a twist of that color are, really tough to see. Like, the orange is all right, but the purple or the blue is very difficult to tell. At least with my human eyes, it's difficult. Maybe the cameras are doing a better job. But definitely very good to use these things. Do you have recommendations on how to straighten them out or anything like that? How to use these?
Ooh, no, not so much. I forgot about the fact that they're twist pairs. No, I don't have any good recommendations.
I was kind of using my Nipix for it, and it was working okay, where I'd basically put it into this part that's not so grippy, and you can kind of straighten it out, but I worry about that I'm just going to catch some of the insulation and strip it or something like that, and that kind of helps a little bit. But
my recommendation is to learn to live with not perfectly straight wires.
Deal with it. That's a good recommendation, actually. I like that. I was trying to use my fancy little... I say fancy little, but it's my cheap little wire stripper. And for the most part... Oh, that actually worked okay for that one. Trying to do really small bits, it was just absolutely cutting the wires. And not actually doing its job right. So I had to just use a utility knife to strip these. But, of course, now that I'm commenting on that, it's working fine. But yeah, so excellent recommendation using that. I think for the final of this project, I'm probably going to utilize those and just have basically two or a couple of these strand pairs running over to this module and have that coming from the Arduino. So should work well.
Sounds like a great plan.
One thing we did try out, did we do this working on this one together, or did I do this in between streams?
I feel like we started to look at this 2 weeks ago.
Cool.
Because we were talking about how the signals are multiplexed or
yep. Okay.
Or a big grid of switches basically.
Cool, and that's similar to what they use for this thing. It's the same same kind of idea. So cool. So we can talk about this IR thing. Like I said, I don't really know a ton about this. I'm gonna have to dig up the code to actually get that to work. Where did that IR module go? Oh dear. I think it's in here actually. Yep, cool. Let's actually move this camera a little bit. Cool, so here's the IR sensor. just plugged into here. It looks cool. It looks like it has like a little, I wish I could set this camera to be closer focus. I don't think I can. Let's try it. We're going to try it. It's going to be great. I think this is webcam 3. Yep. Okay, are you ready? This is going to be great. Oh, I can't manually focus it. Dang it. I lied. So anyway, this thing looks pretty cool. It has like this little protective shield on it. So this can't pick up any visible light, or doesn't pick up visible light, but just picks up IR. So let's go to this again. So we have G, R, and Y. And I apologize, I'm going to have to download the guidebook again for this, because I have that on the other machine. So we'll just give me one moment. Let me get that all figured out. Unless I did download it. My God. It's okay, it's not right. So have you done much work with surface mount materials and things?
You know, not as much as I maybe would like to. I had started down the path of trying to figure out how to do like solder paste masks for doing surface mount breadboard or circuit boards, but ended up not going down that path too far.
What is that? What does that mean?
Well, when you have a completely blank circuit board, or a circuit board that doesn't have any surface mount parts actually soldered to it, the efficient way to get a lot of surface mount parts soldered onto that circuit board at one time would be to create like a plastic mask that you put over the top of it that has holes only in places where you want solder paste to go, and you basically put it over your circuit board and then hold it down and scrape a bead of solder paste across the top. Kind of, I liken it a lot to like screen printing, right?
Okay,
you have
I was gonna ask.
a film that you put over the thing you want to screen print, and then slide a slider across that just spreads paint in order to screen print something. Applying solder paste is very similar for large surface mount circuit boards. So you basically do that to get solder paste everywhere that you want it to go, and then put all of the surface mount parts in the places that they need to go, and then use like a hot plate to heat the entire thing up to a temperature where the solder paste will reflow.
Sure.
And then and then that's how you mass solder a surface mount circuit board in a DIY fashion.
Boy, that really sounds like a 3D printer would come in real handy for trying to do something like that.
Maybe.
For the masking and stuff?
It might. Those films are very, very thin, and even like the minimum layer height on a 3D printer might be too thick for... You might end up applying more solder paste than you want if your film is too thick.
Really? Okay.
But like I said, I did not really go very deep into that, so there could be some nuances I'm not aware of. And like the hot plates that people were talking about in the different threads I read were basically like electric, like griddles almost. You basically go buy an electric griddle from Target and then set it up so that you have like a temperature gun, a heat thermometer.
Sure.
Pointed at the surface so that you can turn it off when it hits the temperature that solder will reflow. So very DIY.
That's what I love about this stuff, is that I can think of like, oh yeah, we could probably put together some kind of like temperature sensor that turns on and off an electric griddle. That seems okay. Let's get a beefy enough relay.
Yeah.
We could probably build that.
Yeah, it would need to be a pretty beefy relay for how much wattage, how many
Yeah,
watts
no
an
kidding.
electric griddle would take.
Neat. All right, so we're gonna switch over to, and I do a, I'm just gonna update my Stream Deck. That's what we're gonna do. Change my Stream Deck so that we can display. Does that do what we want? Yes, it does. Okay. Thanks, Stream Deck. Sorry about the infinite view thing. Okay, so here's lesson 14, IR receiver module. So this is not English as a first language, not written for English as a first language, which is funny for me to mess up. Excuse me on that sentence. But let's figure out what these mean. These pins mean. So ground, VCC, and data. So the third pin, let's just make sure that these are labeled right. So we have G, R, and Y. So make sure what those mean.
Green, red, yellow?
Yeah, green, red, and yellow. The universal, I don't know. It's not really telling me right away. I hate that.
On the picture, they had some colors coming off of the receiver module.
Yeah, so I just don't know what the orientation of this is. Right?
Oh, yeah, I see what you're saying.
So, but G for ground is probably right. This is even better. This does say, so G for ground, red for 12, or for, not 12 volts, for 5 volts, and then signal is on Y. So let me get that plugged in. I really like this little prototyping panel that came with this inventor's kit. I think this has been really cool to use this. Okay. So now we have that. Oops, I still need to get the code for this. My bad. Let me check something here. There we go. Okay, so I'm gonna go and let's try and find this on Google, huh? I think that's another thing that's been really difficult is actually getting the resources for this kit have been a little difficult to download the right stuff because they're so similarly named. It's been a challenge to find the right one.
Yeah, that makes sense.
Oops. Gotta remember to do all these things with more of an incognito. Okay, well that's downloading for a little bit. Let's have that all wired in. Let's see, what else did they recommend for the wiring? Okay. So, right. So that's all they have, and then they have it report to the serial monitor. So once we get the serial monitor thing working, I think it'd be fun to try and get this to control something, like controlling some LEDs or what have you. What it doesn't explain is like how this thing actually works, right? Because I understand that it can read and control, like the remote does some pulse width modulation kind of stuff, but I'm not really sure. Like, how does an IR remote know which button you're pressing?
Based on the 2 seconds that I was reading some of the front matter of this guide, it would seem that the remote is sending a certain hexadecimal code to the IR receiver based on which button is being pressed.
Okay.
And it's up to the software that's interfacing with the receiver module to sort of interpret what each hexadecimal digit or code is being sent from the remote.
Sure. Okay.
Does that help at all?
It does. So then, like, figuring out like what each of the codes are is important. Then, what each of the hexadecimal codes are.
Yeah.
Does it change per remote? Do you think?
It's just a number. No, probably not. Every remote probably. Well, when you say per remote, you mean like different IR remotes from different manufacturers and different button layouts, or like multiple copies of the same remote?
Different remotes from different manufacturers.
I am confident that different remotes from different manufacturers would have different codes associated with each button.
Sure.
Maybe like common types of buttons, like a 1 will always send a hexadecimal code of,
sure,
0x01 or something. There could be some common codes that are used, but I wouldn't count on it.
I wonder if you can find like data sheets on just whatever, like remotes from your DVD player or something.
Oh yeah, I bet you could.
People have figured that out. Because at the end of this, what I'd like to do is to use this receiver to figure out how to use just like whatever kind of remotes for whatever kind of projects. It'd also be fun to have like an IR, not receiver, but a whatever's at the end over here, whatever the business end of the actual remote, to send some infrared code out. I think it might have something like that does that in here, but I'm not sure.
An IR transmitter.
Yeah. That seems fun, right?
I mean, all that is an LED that is emitting in the infrared spectrum.
Yeah.
Honestly.
Sure.
Very simple to control.
But there's one just like in here.
I think I've played with a few IR LEDs over the years. I did a lot of stuff with Wiimotes. Wiimotes were like notoriously easy to, I don't know what the word you would say is, hack or like use in home projects.
Right.
And there's been a lot of people who have made a lot of really great like code libraries and stuff for using Wiimotes.
Okay.
In Arduino projects, and they are all totally, Wiimotes are totally based on IR IR technology.
Cool. What kind of how could someone utilize a Wiimote? Is it just like a general like joystick input, or?
All Wiimotes have accelerometers in them, and it is very easy to get the accelerometer data from a Wiimote, so you can use it for just like orientation tracking. They have IR sensors on the tip. If you remember like what a Wiimote looks like, there's like a black film on the tip of it that hides or houses an IR receiver. And so you can like get IR data from it.
Cool. What did you care to share any of the projects that you worked on?
This was like 8 years ago. But I think I had started trying to look into just doing like general remote control with a Wiimote.
Sure.
trying to like get some servos to move in accordance with like the Wiimote's orientation.
Sure.
Like using a servo attached to another servo to sort of move in 3D space.
Oh, cool. Like controlling a robot arm?
Yeah, kind of like that, using a Wiimote. It would basically try to like mimic the Wiimote's orientation.
That's cool. So just checking to make sure you all can see that okay. All right. Okay, so here's this project. I think I'm missing a library that I need to add. I'll click verify just to see how it does compiling a sketch. Yep, it's missing the iremote.h. So we're going to go to sketch, include library, and go to add zip library. Go to... All these windows are so small. What the hell? Well, it's a zip file. Oh, why would it do that? I just tried to add the entire thing as a zipped library. Oops. These, so my screen is this is a 4K laptop monitor, and there still are just some things that get just so confused. Okay, English. I have no idea why my icons are so small. Okay, so we've added that. Let's just verify, make sure it's all good to go. Okay, so we do have all the libraries in here. So what it's doing is, here it's declaring the objects, and should I zoom in a little bit for you?
This is pretty okay for me.
Cool. So signal pin 11, which is what I'm using. So using the translate IR function. Then it has this case, and this is something I was going to ask you about. Is I'm not familiar with switch or case at all, and I'm wondering if it's part of this this particular library or if it's something that's common.
It's a very common C++ code construct, switch and case statements.
Okay.
I would call it sort of an optimization of, or sort of a more efficient or alternate way of doing a ridiculous number of else if statements. So basically you could...
Oh no, I'm losing you. Zenhaver, do you read me?
Serial.println power.
Wait, we lost you for a second there. Can you try it? Can you say all that again?
Yeah, I think my internet perhaps paused for a moment there since the stream cut out for a second.
There was a hiccup.
Yeah, so like you could write an if-else-if chain of statements that was just like if results.value equals ff_a25d, and then in the body of that if statement do serial.println power.
Mm-hmm.
And then an else if results.value equals ff_e21d, the next one.
Sure.
You could do exactly what this chunk of code is doing that way, but a more efficient and easier to read is to say, okay, I want to make a switch statement based on this one value, which is results.value.
Mm-hmm.
And then you define a case for each of the possible values of that value that you want to define a different piece of code for. So you say case ff_a25d, and then you put in the code that case statement should execute if the results.value is equal to that.
That seems super useful.
End it with a break, and then break signals that, okay, that's the end of that case's code. Then you define the next case, so on and so forth. And then at the very end, you have a default that if there are no cases that match what what value is being switched on, you execute the default.
Sure. That's cool. I'm just curious. I'm going to see if this uses. Yeah, it does. This is the macro keyboard, and here we have switch, and then different cases for different things. So key 1, case 1, case 2. So this is just a long form way that he's written this out, looks like.
Yeah, I would 100 million times prefer the way that the macro keys switch statement is written, just as far as the style goes. This is much easier for me to read.
Excellent. It is more of the standard. I see that they're trying to fit a lot into one spot, but this seems less human readable.
I would even go so far as to say every break should be on its own line too, but you can optimize it and crunch the line numbers down as much as you want. But for ease of readability, I would prefer basically everything to be on its own line in a switch statement.
Interesting. This doesn't look like hex, does it?
What exactly do you have selected? I'm a little bit behind.
The last case looks like more than 6 characters.
It looks like 4 bytes, yeah. I wonder why there's a... I wonder if the remote is always sending 4 bytes, but every single one of the other cases starts with a 00 as the first byte, and it's just omitted.
Would we be able to tell from this or not?
I don't know.
That's that part. So we have our default.
I'm not sure why the last case is 4 bytes and everything else is 3 bytes.
This is the debouncer, right? This delay.
Yeah, I would say that acts as a debouncer.
Cool. So N translate IR. So IR receive, enable IR in. So this is basically just taking the... So this is where the start the receiver thing is a little confusing to me. And
so
the fact
that is definitely a function that's a part of that special custom library that's being used.
I receive, decode results. Do we have the IR signal? So let's see if we can get this thing to break like it was breaking before. I'm not sure that we can, but it'd be cool if it just worked. That would be good also. So when I did this initially, it worked fine for the first time we went through it. And I'm going to go to the serial monitor. Looks like we have this sent over. Just about. Nope. Okay. Couldn't find board on port. Check the other correct port selected. I'm still not completely crystal on what the various ports mean and why it seems to switch and have issues.
Yeah, I don't know the answer to that. I mean, each COM port loosely could correspond to a USB port on your computer.
Sure.
But it's not clear why it would have changed or changed selection.
From one project to another, we haven't really done anything.
Yeah.
Different. Still just having a hard time. It's not quite done. I'm even getting a spinny wheel of death here. Should I try like the reset key on my Arduino or something?
I guess it couldn't hurt. It's something's going on here. I just don't know what.
Oh. Let's just try that again. Back to our spinning wheel of death here. So could this be caused by some kind of error in the library or something?
Seems unlikely because it's getting hung up on the uploading portion.
Sure.
Seems like it compiled it just fine, but now that it's trying to upload it to the board, something is getting messed up.
And this is where I was having some trouble before. I'm not using the Arduino board from the kit. I'm using a different Arduino board. I wonder if that could have something to do with it.
That's interesting.
But that also doesn't make a ton of sense because this is also an Arduino Uno.
Yeah, that it just doesn't seem like it should matter what board you're using.
So, yeah, and it's only this sketch that I've had this trouble with. And I was kind of thinking that maybe it's something to do with like, it's like trying to do some kind of action and isn't able to do it. I'm just going to re-upload my blank one, or the one we used for the, although that may not be a good idea because this needs to be set as an input.
Yeah, I would say try just uploading some random other program right now.
Let's do a blank sketch. Well, I guess I don't have anything in here. I have to...
You could try unplugging it, closing the other sketch that you had previously uploaded to it, and then just starting fresh with the IO receiver module sketch.
Sure. Plug it back in. Still getting hung up.
I'm not sure. You're certain that the USB is plugged in to the right computer, or...
Yeah.
Okay.
We just used the same USB cable for the other command. Or for the other thing we were just doing.
Did you close out... Did you completely restart the IDE at all?
I didn't. I didn't completely close the IDE. I will do that now. Sorry for the infinity, everyone. Get that loaded up. Okay. Compiling sketch. Uploading. Spinning wheel of death. I saw some blinks happening on the Arduino.
Very odd. I don't think I know what's going on here.
Shoot. Hey, you know what though? That's comforting because I sure as hell didn't know what was going on last time. So that's good. It means it's an actual problem.
Were you able to upload it to the board last time?
I was able to get it the first time I did it. It worked fine, and then afterwards I was having some trouble getting it to do. I was running into this problem where the board didn't want to update after I did that. So I don't know if something like that could happen, like something gets screwed up on the board from the software, or if these things are pretty resilient.
Yeah, that seems unlikely that something you would have uploaded would screw up future uploads.
Right? I didn't think so. It seems like it should be basic enough.
Yeah.
But
just try unplugging the IR module, maybe? Just as a Hail Mary.
Like the IR module's interrupting it or something weird?
If it was trying to use too much current, maybe.
Oh.
It could, like, I don't know, maybe mess with the download.
Okay, it's trying. I'm going to close the IDE altogether and try again. That's an interesting prospect, though. I have just an IR receiver LED, but I don't have like the resistor and stuff for it. Or I would have to like add the resistor to the situation. I'm gonna try just uploading a blank sketch and just see if that works, because that was
Sounds
working.
good to me. Yeah.
So just a blank sketch. I think when I was downstairs, I had to like switch ports or something like that to get it to work again. Yeah, it looks like it's bugged out. So I'm gonna do that. I'm gonna switch ports here. I wonder if this is, if I didn't have this exact same problem downstairs, I would say that I just have too many USB things running at once. But this is very similar to what was going on downstairs.
Yeah, even having a bunch of USB things at the same time doesn't strike me as something that would be immediately wrong.
Right. Well, we have one available here that I can use on this side. I'm not using my remote mics right now. How is the audio? Does the audio sound okay? A little far away from time to time?
I'm not a good person to ask because I'm not on the Twitch audio. I'm on the Hangout audio.
Sure. Okay, so this is a COM port that I know has bandwidth. Reset the Arduino. So it compiles fine. Let's upload it. Yeah, this is exactly what was happening to me before, so I don't know what's going on. But it seems like the IDE or Arduino is having quite a bit of trouble uploading any code now.
So even the blank sketch couldn't be uploaded?
Yeah, even the blank sketch is fighting me right now.
Yeah, I don't know. I would maybe normally recommend like a restart of your computer, but that would mean taking the stream down, which is not a good idea. So
right.
Is the IDE process still running? Would you have to kill the process?
I don't know. Let me see. Check out my task manager. I'm not seeing anything. No, I don't think the process is still running at all.
Very odd.
Let's because I have this one right here. Let me just grab the cable for this and let's plug this one in and see if we can get this Arduino to work now.
Yeah, sounds like a good idea.
Problem though, this cable is tiny, so this will have to be somewhat off camera as I plug this in. Because cord just ain't long enough. Got this crazy old school USB. I don't know if it's actually old school or if it's just... I feel like I associate it with like old printers I was gifted. Scanners and stuff.
That's like a USB...
A?
Yeah, I can't even remember the nomenclature for it.
Well, this is blinking and doing stuff. Let's see if we can get a sketch to work. We got some standard blinkies. Let's just as we do this, we can get it on camera there still. There it is. In all of its glory. Okay, we're just going to do our blank sketch here and try and get that to upload. So this is still an Arduino Uno. Oh, I wonder if it defaulted to Arduino Micro when we rebooted it.
Oh, interesting.
That says Uno, okay. So this says Uno. Just gonna upload a blank sketch. Oh, I think you might be right. We might be in restart computer territory pretty soon. Okay, this does look familiar. So,
different COM port.
I was getting this serial open thing. I don't know what that means. Could be the COM port though. COM9. I guess I have both of them plugged in right now. So that worked. I don't know which Arduino I actually uploaded that to. Let's unplug this one. Okay, so yeah, so this Arduino is working fine. So let's see if we can get this to work with our IR receiver sketch. Right? That seems like a thing to try now, right?
Yes, I think that would be a very good next step.
Meanwhile, I'm going to prepare our adorable breadboard. Hey, it worked. Okay, so I'm going to bring this over then. I don't know what we learned, Zenhaver.
Yeah, I don't know either.
I don't know that we learned anything. other than maybe my Arduino from the SparkFun kit is having some trouble today. But maybe we can get this to work. So this is, I don't know. It seems weird because I was having so much trouble starting at this sketch the last time too. I think that's just where I'm just a little sketched out about it.
Yeah, I agree.
Okay. So let me put this back over here. Oh. Yeah, I think there is a problem with this. I plugged it in, and it's immediately having problems. Like my Arduino went offline after I did this.
Oh man, so weird.
So I think, I don't know. I don't see any kind of short or anything like that on here. Oh, and unplugging the IR module made it power back on.
That is super interesting, huh?
Could that be just like a short in this module or something?
Yeah, it's possible if there was a short and all the current was just being consumed, forcing the Arduino into like a constant reset cycle. That would make it so that you couldn't upload any code to the Arduino if it was just constantly resetting itself.
And when I took this module out, it's warm. It's like warm in my hands.
Like just warm or hot?
Just warm.
Wouldn't be surprising to me.
Just warm.
Warm is not surprising.
Okay. But I think it's worth not using this dang thing anymore, huh?
That seems to be kind of the path that I'm going towards in my mind. The module itself might just be junk.
Yeah. Interesting. So I do have... God, I don't know where I put it. I think it might be in here somewhere. I do have another IR receiver dealio. I think it came with this ESP kit. Yeah. So we could, if this ESP kit actually came with any dang instructions, of course, we could find some. But it's basically, I have the receiver from this module, just not in the module here. I think it's the exact same one. Oh no, it's a little different. Same. On the back, they both say 183B. This says 1838, and this one says 1838B. So,
interesting.
But they do look quite similar. Very similar design. So, if I knew like what kind of resistor I needed or something like that, we could just use this. But I think maybe we'll have to shelve this project.
Yeah, that seems a bit involved. It's certainly not an insurmountable problem, but one that maybe would require more time.
Yeah, I agree. So yeah, so that's that project.
We were close. We identified. I feel like we successfully troubleshooted a problem.
You're right. We did. Ooh, this is an IR emitter here. From the
that is definitely different.
So maybe I'll have to dig into how to use this at some point. I think these 8266s are sometimes used as people made them into the kilo or the like remote, the TV turning off remotes. What do they call it? Like a
Oh yeah, I know what you're talking about. It's basically
kill a switch or
universal
something?
like TV turner offer.
Yeah, that seems useful.
Walk into a bar and just decide you don't want to see what's on the TV anymore.
Yeah, well, thankfully I'm never going to have that problem again. Or at least for a while.
Yeah, bars are so 2019.
So 2019, no thanks. Well, what, I did have some other switches we could play with tonight. I'm kind of flabbergasted.
We could see if the operative side of the relays work as expected, or did you already do some of that last week, like the not the control side, but the actual business end?
Oh no, I never did any of that testing. We could do that. Sounds great.
Yeah, we could wire something up to one of those switches, the relays.
Yeah, let's do that. Let's do, and why not just do all 4 of them at once, right? I guess maybe
go big or go home.
Go big or go home is right. So what I'm thinking is we'll actually utilize one of these adorable breadboards. That's what I'm thinking. What were you thinking?
That sounds great.
So slap in some 330 ohm resistors and some LEDs. Hook them up to be powered through the relays. That sound about right?
Yeah, you could like let's see. You could wire the LEDs such that they were just wired directly to power and ground, but insert the relays into the circuit to break them. So like hook them up to the normally open hook them up between normally open and common so that it will become closed when the relay is activated. Does that match your understanding of how relays would work?
Yes. Yep. So were you saying to have like one resistor that then switches LEDs, or each LED gets its own resistor?
Each LED gets its own resistor.
Okay. Yeah, so we basically just use the relay as a switch, right?
Yeah. Yeah.
Okay. So remind me again, anode and cathode. Cathode is ground, right? Or did I get that backwards again? Do you remember which is anode and cathode? What they mean?
I just had to look it up again. The positive is cathode.
Dang it.
The negative is anode.
So an for anti. That sounds good. Cath for Kathy. So LED, the anode is the shorter.
Wait.
Is the shorter one, right?
I think I messed up on an LED. The positive side is an anode, and the negative side is the cathode.
Do they not universally?
Is positive lead. It seems no.
So anode is the longer one on an LED.
The anode is the longer one. Cathode is the shorter one. I feel like the way that I have been taught to remember this is cathode, which is the negative one, starts with cat, and cats are generally very negative, standoffish creatures.
Rude.
So that is how you remember that cathode is negative.
I mean, some cats, sure, but like all cats, it's kind of it's harsh, don't you think?
A little bit, yes.
So where to put my bag of 330 ohm resistors? It's kind of a mess in here, gang. Got too many bundles of deals. baggie with them already pre-bent. Just how I like them. Dang it. Okay. We're just gonna have to make some new ones. That's okay. Oh, but that requires finding the... Oh, I do have this little map here for telling me which ones are which. So... Any tips on reading resistors? Resistor bands and things?
I basically always need to refresh myself when I need to actually do them.
So there's 4-band code and there's 5-band code. Seems hard.
4-band is like... First band is the first digit, second band is the second digit, third band is like the power of 10 to which you are applying those 2 digits, and then the fourth band is like its accuracy specification. Does that sound right, according to that little card you have?
I think what we're going to do is we're going to go with just how they're labeled on the bottom of the strip, because goddamn.
Sounds great.
Because like just looking at this thing, it's like 2%, 5%, 10%. You know, first, second, and third band.
See, the percentages almost don't matter at all. That's like the accuracy specification of the resistor. The
okay.
First bands are the more important ones that give like the values associated with each color. Sorry for the typing.
Yeah, you're good. These are 330, or so it says. Got those put away perfectly. Okay, so we need 4 of these. I'm so amazed at the surface mount ones at how much smaller than a grain of rice they are. They're just like incredibly small.
Oh yeah, it's absurd.
Like it really, you know, I know that they're comparatively huge compared to actual small things, actual small electronics, but it's just so dang impressive at how small they can get. Now, refresh my memory. Do you know if I need to put the... does it matter whether the resistor's on the positive or the negative side? It shouldn't, right?
Nope. All it's doing is limiting the current throughout the entire circuit.
Not from a specific direction.
Nope.
Do diodes reduce from just a certain direction, or does that not make sense because it's meant to be a loop?
Diodes are directional.
But if you're going to reduce the current on something, it's going to be either the entire circuit or nothing, right?
Yes. Current flows through a circuit, you know, in a loop, and so it will be constant throughout an entire loop.
Oh, that didn't work well. Whoops. I like very carefully bent this just right. Just right, and then I forced it in to the breadboard in not a very nice way. This breadboard sure is tight. Yeah, I definitely need to get like an extra little screen for when I'm doing this, because that's really hard for me to tell what's actually visible in OBS while I'm doing this stuff. So I apologize, I'm not giving very good views on certain things as I'm working on these projects. But it's very difficult for me to tell what I'm up to. But I wanted to build this in this manner. So each of these cameras are on a spring clamp, just a regular old spring clamp, and then I have a ball joint camera tripod mount attached to each of the spring clamps with a webcam attached to it. Works pretty good. I'm definitely going to do, I think at some point, the next time I make a big batch of fried rice, I think that's one of the more exciting dishes that I make. I'm going to live stream it, I think, or at least record it.
That sounds like fun to watch. I always enjoy watching you make big dishes of food.
It is pretty fun. So I'm going to utilize these little jumpers. And thank you, that's a fine compliment. How long are these? So I just want to get everything over to this side of the breadboard so it's easier to deal with when we're doing the relays. It's kind of fun. As you can probably tell, I'm enjoying making things kind of neat.
Yes, it's very satisfying, for sure.
I know this is not strictly testing any relays, but this is also very entertaining, so I don't know how much I can stop myself. So I'm trying to think of what are some of the next projects I'm going to be doing. I'm going to be working on the treadmill project for our friend, the dog, Penny. I do have some of the switches for that. I was kind of showing this, I brought this up before to talk about it, but I have this like little toggle switch here, and I think this will suffice for the switch from dog mode to person mode on the treadmill.
Yes, that looks great.
So that's something that I'll try that out. And I might even, for that project, I'll probably make a similar relay panel for that project as well. But I really want to figure out some good ways to create a housing for that project. You know, like doing the CAD work in Tinkercad or something. It'd be fun to have a nice enclosure.
Yeah, very satisfying.
Okay. Nice and neat. This seems like a useful thing just to have set up, doesn't it? Like
could be good for like testing, yeah.
We've built this exact setup many times, just in doing the testing for learning this stuff. So it might be nice just to have this set up like that. Okay, so next we are going to so we want to we'll hook up all of the positives. So we're looking at this thing here, and we're actually running this. If this Arduino still works, we'll run positives to all of these, and then we'll hook the negatives to the common port on the relays. So on the center pin to the relays.
Yeah, I think that sounds about right.
And then
yeah, positives. Yeah.
Just go directly to here, and then the then from here on the normally closed, we'll put that onto the to the negative of the LED. Right?
So we want, so when the relays become active,
yep,
we want the switch to become closed, right?
Yes.
So that means normally, so we will want to hook up normally open and common as the two parts of the relay that we want to use, and we won't use normally closed at all.
Well, that's, so if we use, would that mean that the LEDs would automatically be on until the relays are powered?
Normally open means that, in my understanding, when the relay is not active, it's in its quote unquote normal state, right? And so then when you activate the
I think
relay, then it, am I backwards here, or?
I think you might be, because when the switch is closed, that means that it's a closed loop, right?
That is correct. We want, when we say the relay is active, that's when we want it to be closed.
Sure. Yep. Okay.
And so I think of it, when I think of a relay, I think when it is inactive, it's in its normal or fail to state.
Sure.
So until you apply the signal to the relay to turn on, hooking something up between normally open and common will be open, because it's normally open when it's not active.
Gotcha. Okay, yep, that does make a lot of sense. Thank you. Yeah, I did get those backwards. I'm gonna do one of these. There we go. Okay, so now we want these guys. Boy, what a little mess of jumpers. I think that is one of my requests for some 3D printing help, is something to contain these wires, because good lord, all of these jumper wires are just getting out of control.
Interesting. I have something that immediately comes to mind as something that could be a useful way of organizing them.
Wonderful. That's what I like to hear.
But I don't quite know how to design it, so.
No, well, maybe.
Anyway,
I would love to do a Tinkercad stream where we maybe we could design something together in Tinkercad, or if you give me requirements, so I could do some of the Tinkercadding. I don't actually know how well that would work, but maybe.
Yeah. Could be fun to think about.
I wonder if Tinkercad has any like Google Docs kind of behavior, like you can both be working on something, or actually that seems dreadful. Could be bad. So I'm just giving myself some extra room by putting this over on this side. Okay. And then...
Okay, so you are connecting... Is that power or common or ground that I'm seeing connected to all those different parts of the LED?
This is power.
Okay, so power is going to one end, and the other end will go to...
the relays.
The relays, yep. And then you'll have to connect the common terminal of the relays all to ground?
Yes.
That sounds perfect.
Okay. So, all the wires up here. So I'm going to use the ground rail for this as well. This is going to be kind of a mess, huh? Oops. And I do see that it is 10 o'clock. I don't know if you would want to, probably want to wrap this up pretty shortly.
Yeah, not too much longer, but this project seems like it's coming close to fruition, so...
Might not take too long. I kind of don't like these connectors. I see a lot of people using these screw terminals like this, but like I feel like it doesn't take a lot for them to pull out.
I love screw terminals.
You do?
They're one of my favorite kinds of connectors, yeah.
Maybe I'm just doing it wrong. You know? Could be the case. What's your top 3 reasons why Zenhaver likes screw terminals?
They are easy. They're still relatively easy to attach and detach things as needed, but they are significantly stronger than just like a breadboard having wire plugged in. They're sort of a great like semi-permanent terminal connection.
Okay.
If you're not quite ready to solder wires in place, but you want something to be fairly durable, I think screw terminals are the logical choice.
Okay.
That's pretty much it. That's my only reason.
I appreciate that. And I think that seems accurate too. Like I think I'd agree. I would agree with that. Relays are probably one of the things that I've had the most experience using, just with some of the automotive relays that I've used for my truck light project.
Ah, yes, makes sense. Yeah, yeah. Relays are pretty common in automotive applications.
Mm-hmm. Got those. So now I'll do green, orange, white, and blue. So we want normally open, right?
If my understanding of relays is correct,
Sure.
I believe that we want to hook these to normally open. But if we're wrong, nothing will go wrong.
Right.
Like nothing bad will happen. It will just work the opposite of what we want. Basically, the LED will turn off each time that you would activate the relay. So
very low stakes.
Yeah.
This is getting to be a lot of wires to look at.
Are your eyes beginning to cross?
Just a little bit.
Is your brain going fuzzy?
Slightly. This does make me really curious about doing some PCB design. Doing this kind of stuff. Seems like it could be a lot of fun. Especially if there's good applications that can help out with it.
Yeah, I mean the feeling of like designing a PCB, getting it and soldering everything together, and then having it actually work is unparalleled.
Good. Well, and just like having a purpose to do it, you know? Just coming up with a design or something that's needed. It's kind of like the, the functional print thing. How fun that seems, having a functional print. Actually gonna move this to this part. Okay. Last one to do. Sorry if my arm is just in the camera. Let's do this. Yeah, I think I will make a little LED testing board. Okay, so that's everything. So here we have ground to the ground rail to ground rail, and then 5 volts to 5 volts rail, 5 volts rail to 5 volts rail, and then 5 volts to the LEDs. Then we have ground and all the control wires going to the relay board here. We'll have to rewrite that relay sketch because I deleted it without saving.
You're certain that the anodes and cathodes of the LEDs are hooked up in the correct orientation after having wired power and ground in?
No. I am not certain. Let's test that. We might have to flip these. So the long wire is... Oh, I had that backwards. I get so confused because that RGB LED has the longest pin as the negative, as the ground. But with these single LEDs, it's actually the short pin is the ground, I believe. Let's look at the manual, see what it says. I will remember this someday. Not today, though. Today is not the day. Yep, the long pin is positive, so I do need to flip all of these around. Thank you for calling that out. It's a little cramped to see what's going on. Okay. Cool. Got those. All the negatives are hooked up through the relays and to the normally open part of the control side of the relay. So if I can get my USB cable in here, we should be good to go. And provided we can upload a sketch to this still.
Yeah, that is true.
Oh.
Does it have the old code still running on it?
Yeah, it never actually uploaded the new code. So
that's very handy.
It is very handy. And
it appears like it's working perfectly.
Working flawlessly.
Kudos, hats off.
Yeah. No, my hair's a mess, but yeah. All right, I'm psyched. That worked great. That's very satisfying. It'd be more satisfying if I knew I could upload code to my Arduino still, but I think that's another project.
Well, if the Arduino is currently operating and running code, I am super confident that you will be able to upload code to it.
Sure. It's kind of all or nothing.
Yeah.
If it's fried,
it's fried. For you to be able to be unable to upload code to it would mean such a catastrophic failure that it probably would not be running code like it is right now.
Fair. Well, then I think some of the last steps I need to do is I should really number these relays.
That's a good idea. Yeah, numbering them and then assigning those numbers to the inputs.
Yeah.
On the bottom.
Yep, I think that'd be good. Cool. So I think in the meantime, I might do it on stream, might not. I'm going to turn this LED testing setup into one of these prototype PCBs. I'll solder everything in just so I can use this as a quick testing module. I think that will be a really handy thing to have on hand. And I will also, I think, be doing a stream of the second one of these. I think I'm going to do another one of these keypads and kind of go through all the steps. So meantime, I might have to request some 3D printing assistance with some keycaps, I think, for this.
I would be more than happy to oblige.
Sounds great. Otherwise, I'm gonna have to just hit these keypads with a sandblaster or something. Although they're all for different parts of the keyboard. I don't know if you can tell, but their like heights are all nonsensical, and they're at different pitches and angles and things.
So it's like, yeah, I did notice that.
Really
That's
would be.
Funny. It's a Frankenboard.
A Frankenboard for sure. So, all right. Well, I'm gonna stop this stream here. Thanks everyone. Hope you had a good time, and we'll see you next week.